Hey, I said
Okay.
less. This was the one that was like, you're gonna vomit.
Today, we're gonna graph. The difference between sketch and graph is a graph is exact, sketch is like a rough draft. When we graph, the first thing we're gonna do is make a sketch. Kane.
Dude, this is gonna be in the video now. His name.
What?
Okay.
What?
She just said your name on the recording. You feel blessed.
Alright. When we have a equation in standard form, that means everything is multiplied out. How do I find the degree of my equation?
Or no,
Am I right?
whatever they're called,
What
the
is
Take an
it?
X out.
So add the exponents.
exponents.
Do we add exponents?
Yes.
That's
So
when we
it's-
factor.
Oh. What? Never mind.
It's the biggest exponent. What's our biggest exponent?
4.
4. So our degree is 4. What is my leading coefficient? Plus or minus?
Positive.
Plus. So my end behavior, if I got even 4 and plus,
Above.
up and up.
I'm already lost. How do we get 4? Yeah.
It's the biggest exponent. 4 is the biggest exponent.
Oh, gotcha. Okay,
This
got
is 4.
Okay.
Let you introduce.
So why are we changing from what we did yesterday?
We got first step is sketch, second step is graph.
Okay.
Okay, the other thing we talk about is turns. What is the most amount of turns I can have?
3.
3.
Yeah.
And then I can also have 1 turn. Okay.
Yeah.
The last thing we talk about are the zeros of our equation.
And multiplies.
And multiplicity, yes. How do I find zeros?
It's the opposite of what they are.
Yeah, I mean, a twisted way, I get what you're saying. We normally have parentheses, right?
Mm-hmm.
Here we don't. Well, let's get parentheses so that we can make everything easier. Okay, in order to get parentheses, I need to take out what they have in common. What's the most amount of number in x's I can take out? X squared.
Oh, yeah.
I can pull out x squared. If I do that, what's my new first term?
X squared.
X squared. What's my middle?
Minus 2x.
And my last?
Minus 8x.
8. Not x, just 8. Okay. I want to see if I can break it down into more parentheses because I still have problems there. I still don't know how to find zeros. Okay, can you think of 2 numbers that multiply to negative 8 and add to negative 2? 2 and 4, which one has to be negative?
Negative 4.
4. So I still have my x squared. Then we have x minus 4, x plus 2. Those will multiply to negative 8 and add to negative 2. So now that I have that, I can find my zeros. What's the first one I get from x squared?
0.
0. What happens there? Cross, bounce, or swing?
Balance.
Bounce. My exponent is 2, so it bounces. What's the next 0?
4.
4. What does it do there?
Crosses.
Crosses. And my last 0,
Negative 2.
and what's it do there?
Crosses.
Crosses.
I did it.
Okay. Same as yesterday, we're still just sketching. Okay? My zeros are negative 2, 0, and 4. With a sketch, I don't care how far up and down it goes on our Y. I just care about what happens with my zeros and my end behavior. On my left-hand side, should my tail start up or down?
Up.
Up. My first 0 is negative 2. What does it do there?
Crosses.
So I just start up and cross through. Next 0 I have is 0. What's it do at 0?
Bounces.
Bounces. So I gotta come up and bounce back. At 4, it crosses, so, and it ends up. Does that check out with my end behavior I have here?
Yeah.
Yeah. How many turns do I take?
3.
1,
Oh,
2, 3. Does that check out?
yes.
Yeah. So this is my sketch. Okay. Questions with the sketch. Okay. To graph, what I need to know are the numbers around my sketch. Okay? I need to know exactly what my -3 value is. And then I need to know everything in between and then outside again. Okay? I already know that these 3 are zeros, so I don't plug those into my table. But I need to plug in -3, -1, 1, 2, 3, and 5. Okay? The difference between sketch and graph has exact numbers. So let's make an X and Y table. My X values are these green dashes. I have -3, -1, 1, 2, 3, and 5. Okay, does everybody know how to figure out which numbers to use?
Isn't the ones that are used like zero between ones?
Yeah.
The ones like
The ones that are around are zeros.
Yeah.
So like
No,
before and
you-
after and in between.
So like would 1 be 1 be
Say what?
1?
Yeah.
So basically it's
Right.
everything between your 1 and your 3.
and the one from the left or right?
Yep.
Okay.
Left, right, and in between. Okay. Now, you guys know how to graph. Where should I stick those to figure out my Y values?
X. 4
Yeah.
minus 2.
Yeah, into my equation. Now, you can stick it in to this one, but I would recommend sticking it into our factored one. The numbers are just easier. Like, if you try to stick -3 into x to the 4th, that just gets crazy big, okay? So let's do some of these numbers. Let's do 1 first. Is that okay? Skip down to 1.
Mhm.
If I plug 1 in here, what's 1 squared? 1. If I plug 1 into here, what's 1 minus 4? -3. If I plug 1 in here, what's 1 plus 2? What is 1 times -3 times 3? 10 and 9. -9. So on our table, at 1, the y value is -9. Okay? Does that make sense?
So then is that little, like the curve thing supposed to hit -5?
Yep. At 1, it should hit -9.
Whoa.
And that's why we're going to change our sketch into a graph. Okay. Let's plug, how about -1 in? Let's plug -1. If I plug -1 into x squared, what do I get out? 1. If I plug -1 minus 4, -5. And if I plug -1 plus 2, 1. So what's this multiplied out? -5. Okay. Do we all know how to find the y values?
Yes.
So can I give you the rest of the table?
Mm-hmm.
Okay. -3 is 63. No, 2 is -32. 3 is -45. And 5 is 175.
I think I see why we did -1.
This is why you plug it into the factored. The other nice thing about the factored is if you use parentheses, you can just put that in your calculator and you don't have to worry about, is the calculator going to make, to put it to the 4th power, is it going to make it negative or positive? Okay? That's another reason why I like using the parentheses. Okay. Question so far?
This might be really dumb, but isn't there another way to get degrees? Or like the first one, because today we did like the highest exponent, right?
Yeah, so like when you factor, it should match here because when we have it in factored form, we add. So like 1, 2, 3, 4, which matches the highest degree there.
Oh, okay. So if it's in factor, then you add it up.
Yeah, if it's in
Gotcha.
factored, you add. If it's in standard when it's multiplied out, you just take the biggest.
Okay. And then LC is just which way it goes, right?
Wait, so
Yeah,
you don't
if
add
there's
up
a-
the
if
4,
there's
the
a
3,
positive
the 2,
here,
or whatever?
then that's like the only the positive you don't put, right?
Right.
The only thing is if it's a negative, then your leading coefficient will be negative. If there's nothing there, it's positive.
Wait, so that doesn't add up to 9? It's just
No.
4?
When we multiply out our degree is just the biggest one. When we factor, when you have parentheses, that's when you add.
Oh, okay.
Does that make
And
sense?
then turns, how do we go about that?
Take your degree minus 1, so 4 minus 1, 3, and then subtract 2 until
Isn't
you
the
get
same
to
for
0 or
both of them?
negative.
To find the degree, or what, to find the subtract 1 thing doesn't matter if you're in factored form or standard form?
Once you have your degree to find your terms, you subtract 1. Okay. Other questions?
Then zeros is just like, things up there.
Yeah, the zeros you have to get from factored form.
Yeah, it's not too bad.
Okay. Alright. Now we're gonna graph. Only difference is we now have y values for our points. This middle stuff tells you how to scale. Okay? The ends are probably gonna get crazy high, crazy low. So look at the middle for scaling. We're gonna go by 5s. Okay? Because negative 45, well, that'll just be 9. Okay? So, why don't you draw yourself a graph?
What? Yeah, let's just draw that
Yeah,
really
let's
quick.
just pop that on the page.
Yeah.
You can use your back. There's a blank one on your back. If you want to put the graph there.
Okay,
Oh,
and go up by 5.
Go up by 5s. Yep. I'm going to leave my x's just as ones though, okay? Okay, you make your graph. I'm going to redraw the table. You let me know when you're done.
What was it?
Goes up by 5s and side to side by 1s.
Y is by 5s, x is by 1s.
Oh, shoot.
Because you only need to go to negative 3 and positive 5 on your x's. Are we okay?
Go for it.
Okay. What stays the same as our zeros? I still like to draw zeros first, just because I don't know, you don't have to. So our zeros still the same. We have negative 2, 0, and 4. Those are still our zeros. That's still where it crosses the x-axis. Okay. From there, just plot your points. Negative 3, we go up 63. It goes off the graph.
Oh.
The ends are going to get crazy high, crazy low. We just care about the middle part. At negative 1, we get negative 5. So down 1, since we're going by 5s. 1 is negative 9, so about there. 2 is negative 32, 5, 10, 15, 20, 25, 30. There-ish. 3 is negative 45.
This is a lot.
And 5 again gets crazy high.
Okay, well, just a minute.
Okay. Then we just combine our points.
Okay. Um.
Draw.
Nothing, I'm just drawing, so.
It kind of looks like you were going to draw a parabola, but it kind of stroked out or something, and then you just kind of tried to go back at it. Like,
But look at how close our sketch is to the real thing. It's not bad, right?
Looks good.
It doesn't get as low as it should. And there's a little bit
Why do I have
difference.
more points than-
Well,
But you always make sure your end behavior is the same. We're still up. Our zeros are the same. We still bounce at 0, cross at -2 and 4.
Yeah, mine doesn't.
Oh,
I think I have one.
Should you go down to -45 on your 3?
Yeah, I just have.
I missed the 0.
What was your -1?
-1 should be -5.
What's your positive one?
Positive 1 is -9. So it should just be down 2, because we have 5s.
I drew a point down here for some reason.
Okay. They don't have to look perfect. I don't expect perfection. Can we go on to the next thing?
No, I just perfected it.
Okay. The next thing we're going to talk about is writing polynomials in factored and standard form. What standard form means, that's that first thing you saw. Standard form.
Here, what is that?
Oh, no. Okay. Standard form is when it is multiplied out. So when we add or subtract in between. Factored form, you just have parentheses multiplied together. Okay? You pretty much already know how to do this. That's the sweet part. We're given zeros. If I have 3 as a 0, what's the parentheses associated with that? Yeah, x minus 3. If -2 is a 0, what's my parentheses?
X plus 2.
X plus 2.
Wow.
This is factored form. To get standard form, we're just going to FOIL. Okay? FOIL x times x gives me
X
x squared. X times 2
2x
plus 2x, -3 times x,
minus 3
minus 3x, -3 times 2,
minus 6.
-6. Then we combine like terms. X squared minus x minus 6, and throw y equals out. This is standard form. Questions? Okay. 2 you're used to. We FOIL. Now we're trying with 3. Finding our factored form is the exact same thing. If my 0 is 1, what's my parentheses? X minus 1.
X plus 1.
And then x plus 1, and what's my last one?
X minus
X minus 4. Okay. When you have more than 2, you gotta do it in steps. Yes, some of them will get long, but then you make less mistakes. Okay?
Track. That's what they
We're
call
gonna
it.
do 2 at a time. We're gonna do these 2 first, and we'll bring our x minus 4 along. Okay? If I have x times x, I get x squared, x times 1 plus x, -1 times x, negative x, and -1 times 1, -1. I like to put parentheses around that, just so I remember that I have another step, and bring your x minus 4 along. Questions so far? The other thing I would suggest is combine your like terms first before multiplying. It'll save you some time. Okay, so let's simplify this first one. X squared, what happens here?
They cancel.
Cancel. So now I only have x squared minus 1, and now I can multiply my x minus 4. Okay. Same thing, I just FOIL. What's x squared times x?
X cubed.
X cubed. What's x squared minus 4, or times negative 4?
Negative x.
Minus 4x squared. -1 times x.
Minus 6.
Negative x. -1 times -4.
4.
Plus 4. Do I have anything I combine here?
Nope.
Nope. So I stick a y equals out front, and that is my standard form. We're not gonna do C, don't worry about it.
What's standard form even for? Like factor form is the thing that you use to graph.
It's just another way to write equations. And you can do them.
It's just standard.
Okay, we got one more.
Oh my gosh, Mr.
Yeah.
You're killing me.
Killing me, Smalls. Okay, we already talked about this today. How do we find the degree in standard form? Degree is
It's in front. In standard form?
in standard form. How do I find the degree of polynomial?
The front one. The front exponent.
Yeah, the highest, the biggest exponent. In factored form, how do I find the degree?
Add them.
Add them up. Add our exponents. Okay, to find the degree when we're given a table, you have to find the number of times you subtract. Now, that doesn't make a whole lot of sense, but it will in a quick second. Does everybody have a written note? Okay. So when we have a table, we want to subtract our y's by the same amount each time. Once we have that, we're done. Okay? Always, always, always make sure you are subtracting, no matter what your numbers are. Okay? So you can go ahead and put subtraction signs in all these if you want to remind yourself. Okay. Are you ready? What is negative 13 minus a negative 4? What is negative 4 minus a negative 1? Negative 3. What is negative 1 minus 2? Negative 3. 2 minus 11? Negative 9. 11 minus 32? Negative 21. And 32 minus 71? Negative 39. That was tough. Okay, what we're looking for is for this number right here to be the same. Is it?
Which number?
This green number.
They're all different numbers.
They're all different.
They're all different, right? Negative 9, negative 3, negative 3. Some of them repeat, but they're not all the same, right? They need to be all the same. They're not. That means we have to subtract again. Okay? So throw your subtraction sign in there. If you want to, you don't have to have them.
And why do we always subtract?
Because we can't.
Because it's math.
Just, that's, yeah. Don't, just don't.
Makes sense.
Okay. Negative 9 minus a negative 3. Negative 6. Negative 3 minus a negative 3. 0. Negative 3 minus a negative 9. Positive 6. Negative 9 minus a negative 2. Negative, or I'm sorry, not negative 2, negative 1. I'm sorry. Negative 21 minus a negative 39. 18. Are these numbers the same?
No.
Nope. Gotta do it again. Negative 6 minus 0.
This is it. This is it.
Negative 6.
This is it. You feeling good?
Hope you're excited.
0 minus 6, negative 6.
6.
6 minus 12, negative 6. 12 minus 18, negative 6. This is what I mean. Look
That
It's probably
was
the most I've ever done
for same.
in algebra. I mean,
Okay. Now to find the degree.
oh my goodness.
To find the degree, it says the number of times we subtracted.
3.
Here we subtracted once. Here we subtracted again. Here we subtracted again. So what's my degree? 3. If it's a degree 3, we call that a cubic. That is the first thing we did. x cubed. What else could we say? I think that's it.
Lots.
Okay.
A swim.
Questions?